The World of Physics with science expert Liam Diaz, Alex Pressburger, JJ Colon Carrero, and Raj Mahal.
We're going to be teaching you about Sir Isaac Newton's three laws. Newton's first law is the law of inertia.
Newton's second law pertains to the relationship between force, mass, and acceleration.
Newton's third law pertains to the governing relationship of every action as a reaction involving an object's mass.
Each law is derived from the prolific scientist Sir Isaac Newton.
Isaac Newton was born in 1643 in Wolford, England.
He attended Trinity College of Cambridge University in 1661.
And in 1687 published the Philosophiae Naturalis Principia Mathematica, which contained his explanations of the three basic laws of motion.
So let's start learning about these laws. Newton's first law states that any object at rest will remain at rest until acted on by an unbalanced force. Any object in motion will remain in motion unless acted on by an unbalanced force. We can see this in the real world example of cars.
These wings are delicious. Roommate, man. Roommate.
Nah, we were just kidding. As I press the gas and then with my foot, the car should remain in motion, right? Is this what happens?
No, we stopped. But if Newton's law is true, shouldn't we stay in motion? There isn't an unbalanced force acting on us.
But Alex, there is an unbalanced force acting on us. It's the friction between the tire and the road.
So you're saying if there wasn't any friction, we would be continuing to move forever?
Yep.
So we already went over how an object in motion stays in motion. Now it's time to go over how an object at rest stays at rest unless acted upon by an unbalanced force. Once again, we'll show how this applies to real life by using a car. See how this car is at rest? Newton's first law states that this car will remain at rest unless acted upon by an unbalanced force.
Now we'll show you the effects of an unbalanced force.
The car was at rest, now it is in motion.
This summarizes Newton's first law, the law of inertia.
To demonstrate Newton's second law, we're going to be using the real world example of weightlifting.
We in here getting jacked and swole like some big meathead Guidos from Jersey Shore. About to be that football season, so you know we getting big in the weight room.
Boys day today, about to be hitting the squat rack. Gotta save work on the cats for another day. How much you trying to put on?
Let's start off with a light 450.
Nah, how about you just put on 45 on each side?
Damn, that's some baby weight.
And that's the point, because part of Newton's second law states that mass and acceleration are inversely proportional. This means if we put on less weight or less mass, we gotta look better for the girls when you accelerate faster.
But I always look good for the girls, bro.
You right.
But my body is telling me
How about we throwing that 450?
Nah, how about we just go to 225 and see what happens?
Good.
But my body is telling me baby,
Damn. That wasn't as easy as the first set. I had to go much slower.
Here's Newton's second law at work again. In addition to stating that mass and acceleration are inversely proportional, it also states that mass and force are directly proportional. Since we add more mass, that exerted greater force to propel you and the bar up, which it did for that much slower acceleration.
Wow, and if I remember right, doesn't Newton's law also state that force and acceleration are directly proportional?
Yep, and we can see this if you take all the weight off the bar.
my body's telling me baby.
Slight work, baby.
See how fast you banged out that set? With your increase in acceleration, you increase the force you exerted on the bar, possibly as much as when you were lifting 225.
Oh yeah, you read again, bro. So, to summarize Newton's second law, he said massive force is directly proportional, force and acceleration are directly proportional, but mass and acceleration are inversely proportional. Hence the equation he came up with, F equals ma.
Yep.
Newton's third law states that for every action, there's an equal and opposite reaction.
We're gonna show you this with the real world example of basketball.
Hey Raj, how about you go out for a layup?
Okay. What the heck, man? What'd you do that for?
Dude, it's just a demonstration of Newton's third law.
How the heck is that Newton's third law?
Well, you see, Raj, my hand exerted a force on the basketball, and the ball exerted an equal and opposite force on my hand.
But I didn't see the ball exert a force on your hand.
Well, did it go through my hand?
No.
Then it repelled my hand and hence exerted a force. Hey Raj, how about you go stand over there and do me a favor and close your eyes?
Okay.
Watch this.
Oh, what the heck did you do that for?
Just another demonstration of Newton's third law.
I have no idea how the heck that's a demonstration of Newton's third law.
Raj, it's just like the first example. The ball hit a force on you, and you exerted an equal and opposite force on the ball.
How could I have exerted a force on the ball? I didn't even freaking see it coming.
Well, did the ball go through you?
No, it just bounced right off.
Well then, you repelled the ball and hence exerted a force on it. Congratulations, you are now an expert on Newton's third law.
So those are Newton's 3 laws in a quick little snippet.
Yep, and thanks for watching our video.
We hope our examples helped you understand Newton's 3 laws.
If you didn't pay attention at all or understand anything, cool.
Peace.
Raj, how was it? It's good? That was it.
We got this. We got this.
Oh. How could I have exerted a freaking force on the... Wait, stop. Published the Philosophia Naturalis Principia Mathematica, which contained his explanation.
No!
Mathematica, which contained his explanation.
Why'd you look at me now?
I don't know, dude. Mathematica, which contained his explanations of the 3 basic laws of motion. Keep it.